Hi, I am Anindita Dash Bhattacharjee. In the previous video, I have discussed on tricks to solve problems on calendar, clock, divisibility, square root of non-perfect number and cube root of large number, along with multiplication and squaring tricks. In this video, I will give you one trick for compound interest which can be used to solve any problem on compound interest, and one formula to solve all the difficult problems of mixture and alligation. Usually, in order to solve compound interest problems, we need to apply formulas. However, let me give you a trick, which is basically the concept of effective percentage. And by applying this trick, we can solve any compound interest problem within seconds. So let's consider the given problem where the principal amount is rupees 12,000 and rate of interest is 10% per annum for 2 years of time period. Let's use the trick instead of formula to save time. So as discussed, let's implement the concept of effective percentage. To calculate effective percentage, the formula will be x plus y plus x into y divided by 100, where x and y are the given rate of interest of year 1 and year 2. In our case, the rate of interest for both the years are same. So x is equal to 10 as well as y is equal to 10. So we put the value of x and y in the formula. So the compound interest is 10 plus 10, that is x plus y plus 10 into 10 by 100, which is equal to 21%. And this 21% is the compound interest of principal amount. So the compound interest is 21% of 12,000, which is rupees 2520. Now try to solve the same problem where the rate of interest is 14% instead of 10%. One point to note here is if the compound interest is in fractions, that is 9.99 or 9.3, then need to consider rounding off. That is, for 9.99, consider 10%. So now, if the time period given is more than 2 years, then how do we use this concept? Very simple. For an example, if the time period is for 3 years, then use the same formula twice. Let me solve one problem for better understanding. So in the given problem, for the same principal amount of rupees 12,000 and rate of interest is 20% per annum for 3 years, let's try to find out the compound interest. So in this case, rate of interest for first year is 20% and also 20% for second and third year as well. So just like the previous example, we will use the same formula to find out the compound interest of first 2 years. So here x is 20 and y is also 20. So as per the formula, we get 44%. So we have got the compound interest of first 2 years as 44%. So now x is 44% and y is 20%. That is the third year interest. And as per the formula, we get 44 plus 20 plus 44 into 20 by 100, which is 72.8% of rupees 12,000. Let me know the answer in the comment section. So similarly, for n number of years, the same trick can be used. There are three difficult and most frequently asked questions in any aptitude exam from mixture and alligation topic. Let me give you a trick through which you can solve all these cases. So the formula to be used for any case is final mixture, which is also known as reduced mixture, will be equal to initial amount, that is without mixing anything, multiplied by 1 minus repeated amount, that is the amount of impurity, divided by initial or total amount, to the power n, where n stands for the number of times impurities are mixed. I know this sounds little confusing, but it would be very easy to understand through problems. So let's consider a problem which states that 5 liters of milk is taken out from a jar of milk of 50 liters and replaced by 5 liters of water. Again, from this mixture, 5 liters is taken out and replaced with 5 liters of water. This happens thrice. So now the question is, what is the amount of milk in the existing mixture? So from the given problem, we can identify that the 50 liters of pure milk is the initial amount. 5 liters of milk is taken out and filled with 5 liters of water, which is the repeated amount, and this phenomena is repeated thrice. So n in the formula is 3. So we can calculate it as 50 into 1 minus 5 by 50 to the power 3, which gives the answer as 36.45 liters. That is the final or reduced amount. If you carefully notice, I have not tried to find the cube of 9 by 10. Instead, 9 by 10 is written thrice. And see rest of the intermediate steps carefully. The formula might seem to be a bit confusing or hard to remember. So, let us consider the initial mixture as I, replaced amount as J, and if we put them in the formula, after simplification, the reduced mixture will be in the form I minus J whole divided by I to the power n multiplied by I. This is nothing but a simplified formula which is easy to remember. Now let's consider this problem which states 20% of milk is taken out from a vessel full of pure milk and is being replaced with same amount of water, and this process is repeated thrice. The question is, we need to find the final or the reduced quantity of milk. We now know the simplified formula to calculate the reduced mixture. So the point to notice here is the replaced amount is in percentage and total initial amount is not provided. Hence, for the simplicity of calculation, always consider total amount as 100 and the replaced amount will be then 20. So as per the formula, I is 100 and J is 20, which gives the answer as 51.2 liters of milk left in the mixture. So let's now consider the most difficult type of mixture alligation problem. The problem states that from a container of milk, 15 liters of milk is stolen and is replaced with equal amount of water. And this is repeated thrice. And after repeating third time, the ratio of the milk and water in the container is given as 343 is to 169. And we are being asked to find initial quantity of milk in the container. So in this case, we can use the same formula in a tricky way. Whenever we get something in terms of ratio, as per ratio proportion concept, we can write them in the division format. Here in our case, we can write milk by water is equal to 343 by 169. Also, point to notice here is, as water is replaced in place of milk, therefore total mixture has 343 plus 169, which is 512 unit. Now here 343 is your reduced amount of milk, but it is in ratio format. So next step is to convert the ratio into the amount. That is, we can write 343x. Now 343x can be considered as reduced amount, and we already know the total amount is 512x. So using the same formula, we get 512x, which is the initial amount, equal to 120. So look at this calculation carefully. We started our calculation with 512x and ultimately we get 512x as 120. So 120 is the initial amount of milk.